All right, welcome back, my future Math 3 honors geniuses here. So the last part is how to solve systems of equations, which you guys, it's a review for you, but then also how to solve them on the calculator using matrices. It's one benefit of knowing matrices. So real quick, to solve a system of equations, this here is a 2 by 2 system, meaning basically you have two equations with two variables. If you guys remember using elimination on a problem like this, where you either want to find a way to match up the x's and eliminate them. All right, so for instance, if I can make this 3x turn into a negative 9x, when I add these two equations together, it would eliminate the x's. So what could I do to make that happen? Well, I keep the first equation the same, but what I'm going to do is multiply everything in the second equation by negative 3, because that would turn this 3x into negative 9x. Then plus 15y equals, that's going to give you 63. Now, when you add these two equations together, 4y plus 15y is 19y. Ends up equaling, what is that going to be? Negative 6 plus 63 is 57. And when you go ahead and divide by 19, you're going to get y is equal to 3. Once I have the value of y, I can basically plug it in to one of the equations. So 9x plus 4 times 3 equals negative 6. Now I can solve for x here. 9x plus 12 equals negative 6. Subtract that 12, 9x equals negative 18, x is equal to negative 2. So my ordered pair solution here is negative 2, 3. So now when we solve a 3 by 3, our goal is to break this 3 by 3 down to a 2 by 2. Now when I look here, the y's are easy to eliminate and the z's are easy to eliminate. And the reason is you have a single y here and you have a single z here, which makes it easy to eliminate the 2z and eliminate the negative 5z. So what do we do here? What I'm going to do is eliminate the z's, right? It doesn't matter which one, all right, but as long as you use all three equations. So first thing I'm going to do is use these two equations and eliminate the z's. So if I have a negative 5z here, I'm going to make this a positive 5z by multiplying everything here by positive 5. Okay, so first equation doesn't change, so 4x plus y minus 5z is equal to negative 13. Then 5 times 2x is 10x minus 15y plus 5z is equal to 55. So when I add these together, I get 14x minus 11y, minus 14y, sorry about that, equals 42. Okay, so right now what I'm going to do is bring that over here. 14x plus 14y equals 42. So now I'm going to focus my attention on eliminating z using the top equation and the bottom equation. Since that's positive 2z, I want to turn this into negative 2z by multiplying the entire equation by negative 2. So the first equation, again, doesn't change. Okay, and when I multiply the second equation by negative 2, I'm going to get negative 4x, and that's going to give me plus 6y minus 2z equals negative 22. When I combine these, I get negative x plus 2y equals negative 4. I'm going to line that up underneath over here. So negative x plus 2y equals negative 4. Well, here's the thing. Now I'm going to take this 2 by 2 and solve for one of the variables. Now there's many different ways I can do it, right? I'm going to find x and y here with this system. So what I'd like to do is just multiply the bottom equation by 14, and that would eliminate the x's. So the top equation stays the same. 14x minus 14y equals 42. The bottom equation now, when I multiply everything by 14, it's going to give you negative 14x plus 28y is equal to negative 56. These eliminate, and I'm left with 14y equals negative 14. And now I can solve for y. And I'd get y is equal to negative 1. Now to find x, I'm going to take negative x plus 2y equals negative 4. And I'm going to plug y in there. So negative x plus 2 times negative 1 equals negative 4. Negative x minus 2 equals negative 4. Add the 2. Negative x equals negative 2. X is equal to 2. Now I have a value for x and I have a value for y, so I can plug it in and find z. So I pick one of the top equations. I'm going to pick the last one because z is technically all by itself. It doesn't matter which one you plug it into though. I'm going to do 2 times the x value of 2 minus 3 times the y value, which is negative 1, plus z is equal to 11. So 4 plus 3 plus z equals 11. 7 plus z equals 11. Now when I subtract that 7, z is equal to 4. Okay, so solving these 3 by 3 systems, the hardest part is getting organized and knowing where to start. I like to work smarter, not harder, so we eliminate the easiest variables and then move along from there. So, how do we do this now? Using the calculator. So, solving system of equations using the calculator. Okay? So, what we're going to do is we're going to call this the variable matrix and the constant matrix. So what we do is we make a matrix up here of using the coefficients, or this is a coefficient matrix, sorry. 9, 3, 4, negative 5. Then the constant matrix is going to be, or sorry, this is times your variable matrix, x, y, equals your constant matrix. Now, what you have to understand is if I were to multiply this 2 by 2 by this, so this coefficient matrix times the variable matrix, I would get this back, okay? So what happens here now is dividing by a matrix. Anytime you divide by something, so say I do 4 divided by 2. That is no different than doing 4 times 2 to the negative 1. Right? Well, here if I'm dividing by, technically I would divide by this matrix. 9, 3, 4, negative 5. Right? And again, if I do 9, divide by 9, 3, 4, negative 5, what I'm basically doing is I'm using the inverse of this matrix and multiplying it by that constant matrix. And when I do that, that would give me my x and y value. So let's take a look here. If I plug that coefficient matrix in, so I'm going to go second matrix, enter. So I'm going to put this in as my, second matrix, arrow over to edit. And I'm changing this 3 by 2 to a 2 by 2. So 2, enter, 2, enter. And now I'm going to put my coefficients in. 9, enter, 4, enter, negative 3. 3, enter it. And then negative 5, enter. Then I'm going to put my constant matrix in. So I'm going to go second matrix. I'm going to go edit. I'm going to go matrix B now. That's going to be a 2 by 1 matrix. So now I'm going to put -6 in there, -21 in there. And when I do that, right, I'm going to quit out. And now, what you have to understand here is when I look here, I'm doing the inverse of the coefficient matrix times the constant matrix. So I'm going to go second matrix, A, and you have to understand the inverse button is x to the -1. So I'm going to go inverse times our matrix B, enter. And if you remember from the front side, what was our solution? X is -2, Y is 3. So our ordered pair solution is -2, 3. Okay, how do we do the 3 by 3? Again, we're going to do our coefficient matrix, 3, 4, 2, -4, 1, -3, 2, -5, 1, times our variable matrix, which is x, y, z, equals our constant matrix, which is 18, -13, and 11. And right away, when I go to solve this, the first thing I'm going to do, I'm going to enter the matrix. Second matrix, enter. Oh, second matrix, edit. Go over to edit. But now that's a 3 by 3 matrix. So now 3, enter, -4, enter, 2, enter, 4, enter, 1, enter, -5, enter, 2, enter, 3, oh, sorry, -3, enter, and 1, enter. Then I'm going to enter my constant matrix, second matrix, go to edit. All right, and that's going to be 8, oh, that's going to be a, sorry, edit, and then I'm going to go matrix B, which is a 3 by 1 matrix. So I get 18, enter, -13, enter, and then 1, enter, oh, 11, enter, sorry. So that happens, I can arrow down, 11, enter, and now, so now that I have both matrices plugged in, right, I have the coefficient matrix and I have the constant matrix. Now all I do is I take the inverse of the coefficient matrix, so matrix A, and then I hit the inverse times matrix B, the constant matrix, hit enter, and when you get that there, you get 2, -1, and 4. What you have to understand is that's x, that's y, that's z. So our ordered triplet, I guess, would be 2, -1, -1, and 4. Okay, and if you look, 2, -1, 4. So using matrices to solve 3 by 3s is much easier. So do me a favor on the you try. Use your calculator, right? And try this one by hand real quick. All right? And then come check it in. So I went ahead and put in here already. If you look, I have matrix A plugged in here, the coefficient matrix. So right away, when you go to do this, if I go second matrix A inverse times second matrix B, right away, when you get your answer, you get 0, 4, and what was it? 1. And that would be your solution. So if I were to plug, how can I check my answers? If I do 2 times 0, minus 4 times 4 plus 1, right? If I look here, 0 minus, what is that, 16 plus 1, that gives me negative 15 equals negative 15. So that ordered triplet makes that equation true. It will make this equation true and that equation true. All right. Make sure you know how to do them by hand and using the calculator, and go ahead and try the homework.